Okay, in this model, we're going to look at pure competition. We have the demand and supply of pizza given by those equations, and they're graphed in the grid below. If you click on this, you'll open up this Desmos model. What we're going to do is we're going to change the demand curve over here in Desmos, the one that is given to you in your problem. We're going to change the supply curve that's given to you in your problem. Okay. And the intersection of demand and supply is the equilibrium, right? And the quantity is on the x-axis, the horizontal axis, and it is 276, right? Between 200 and 400, 276, right? That's the market equilibrium quantity. The market clearing price is the height of that point, right? This line right here is 10, that was 20, so it's just below 20, right? So the second point, or second number in the point, is the price. Okay. Now I can label this graph using my zoom tools. This is the price axis. This is the supply curve. That's the demand curve. And this is the quantity axis, right? And then the equilibrium, the market clears at a price of 17 in my model, right? Okay. Let me delete that because when I scroll, it'll mess everything up. Now, the above supply curve models the profit maximizing decisions of 12 identical restaurants. In my model, I have 12 identical restaurants. So 12 restaurants comprise the supply curve. And because they're identical, right, they're going to split the market equally. What does that mean? Well, if together they're supplying 276, and individually, because they're identical situations, selling identical products, they're going to each supply 23 pizzas. Okay. And they're each going to supply those 23 pizzas per hour, perhaps, at, in my case, $17 per pizza. Right? $17 per pizza. Now, the demand curve, I'm going to let you figure out this one right here. For this reason, each of the 12 restaurants is what? A price taker, a price maker, a duopolist, a life taker, an oligopolist, a heartbreaker. So you're gonna figure out that on your own. With the following demand curve, perfectly elastic demand curve. Now, why do we say perfectly elastic demand curve? So, for example, for the 12th restaurant, customers know that they can buy their pizza at restaurants 1, 2, 3, yada, 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 10, or 11 at $17, right? Whoops. At $17. They can go somewhere else and get it for $17, right? So the first person in line will pay for a pizza from the 12th restaurant is $17. The second person in line will pay for pizza from the 12th restaurant is $17. The 1,000th person in line will pay for pizza from restaurant 12 is $17. That is why this equation, P equals 17, is firm 12's perfectly elastic demand curve. It is also firm 1's perfectly elastic demand curve, firm 2's, firm 3's, firm 4's, yada, 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 firm 10's perfectly elastic demand curve, firm 11's, firm 12's. And these are graphed at the bottom of the page down here. So firm one, this is firm one, Coven Pizza, right? Perfect elastic demand at $17, right? Firm two's perfectly elastic demand at $17. Firm threes, firm fours, fives, 6, 7, 8, 9, 10, 11, 12. So firm 12's perfectly elastic demand curve, right? Notice that the red line here is the marginal cost or the supply curve of that 12th firm. Notice that it intersects perfect elastic demand at 23. See that? 23, 23, 23. So all these supply curves or marginal cost curves intersect the perfect elastic demand curve at 23, quantity of 23, right? Now, since the market supply curve, this up here, since the market supply curve, you can also think of it as the aggregate marginal cost curve for the market. Since the market supply curve is the horizontal sum of the marginal cost graphs of the 12 restaurants. So if I at each price, right? If I at each price add the quantities together. So at a price of 40, right? It looks like the quantity supplied would be maybe 26, right? So price 40, I add 26 up, right? 26. So I can multiply 26 by 12, right? And what I'll get is I'll get this quantity, something just over 300, right? And I can do the same thing with the individual quantities. So the individual quantities are 23 at a price of 17. So if I hold the price constant at 17, each firm's going to supply 23, right? So I can add up 23 12 times, or I can just multiply 23 by 12, and I get this market quantity of 276, right? So it's the horizontal sum. So horizontal sum of the marginal cost graphs, right? And again, these restaurants equally split the market. So if I multiply little q times 12, because I have 12 firms in this market, I get the big Q, right? So the market supply curve or the marginal cost curve can be disaggregated into individual marginal cost curves by replacing Q with 12Q. And I do that here. So this right here is the market supply curve or the market marginal cost curve. This is the individual supply curve, right? Individual supply curve, which is also the individual firm's marginal cost curves. Notice it has the same intercept as the market supply curve. But the individual supply curves are 12 times steeper than the market supply curve, right? 12 times steeper. So again, this is the supply curve of an individual firm in this market, right? And we know from the reading that the supply curve in a perfectly competitive industry is just that firm's marginal cost curve, right? So I replace price, which is dollars per units, with marginal cost of firm I, which is in terms of dollars per unit. I make that replacement. The intercepts are the same. The slope, though, I got to multiply 0.67 times 12. So the slope is 8.04. Okay. And this red equation is the red line, upward sloping line in each one of these graphs, right? Each one of those graphs. Now, under perfect competition, each restaurant's revenue equals its quantity supplied, the little q, right, times the given price, right? So the capital P here is the market price. Little q is the share of firm's I's market output, right? Now, if I replace price with the market price, right? Because the firms are the firms in this market are, they don't make the price, they take the price, right? The slope of the individual's restaurant equation, revenue equation, is 17. This is just a linear equation with a slope of 0, an intercept of 0 and a slope of 17. Okay. Since the slope is the change in revenue divided by the change in quantity supplied, change in R over change in little q, holding all other factors, it represents the firm's marginal revenue, right? When you see slope of something, in this case, slope of revenue, whenever you see slope, you replace slope with marginal. Slope of, in economics, is replaced with marginal. So the slope of the individual's restaurant's revenue equation is 17. That means marginal revenue is 17. And that technically is what this black line is. This black line is the marginal revenue of firm 1. And this red line is the marginal cost of firm 1. And the same is true for the 11 firms in this market. Okay. Now, each restaurant's marginal revenue is graphed as the market price. It has no control over, right? It has no control over this market price. It's shown in the figure I just showed you at the bottom of this problem. Restaurant profits are maximized when each restaurant supplies the quantity that increases its marginal cost to just equal the market price of $17 per pizza. For restaurant I, right, I could be 1, it could be 2, it could be 3, or it could be restaurant 12, right? In my case, I got 12 restaurants. Okay, so what we're going to do is we're going to set marginal cost equal to marginal revenue, right? And what did I do below? This is the equation I derived up there, right? This is the equation up here. So the left side is the marginal cost. The right side, the thing in the box, is the marginal revenue. And the marginal revenue in my problem is 17. Now, if I solve this equation for Q, little q, I got, let me copy this right here. Copy. And then that equals 17, right? Since the firms are identical, I'm going to get rid of the I, right? Now to solve this for Q, I got to add this quantity to both sides. When I add that quantity to both sides, what happens? Negative plus the positive is 0. That becomes 0 there, right? And 0 plus 8.04 Q is 8.0 Q. So now I got to add it to this side, right? Okay, so now what is the right side equal to? Well, this becomes a 4, right? And then this becomes a 7. I carried the 1, so 8, right? Now, the way to think about this is almost 20, right? So I'm going to increase this by almost 20. If I increase it by 20, I get 187, right? But remember, I increased it by almost 20. Right? So this is 3 smaller than 187, right? So now what do I got to do? I got to divide both sides by 8.04. When I divide both sides by 8.04, 8.04 divided by 8.04 is 1. And 1 times Q is Q. Now, I'm not going to try to do this in my head. I'm going to just do this in decimals. So I'm going to copy it. And you get 23. How do I know that? Because it's a little q, right? And we already established the fact that each firm is going to supply 23 units, right? So this quantity is 23. We just verified that this is in fact the marginal cost curve, right? Firms, each of the 12 firms marginal cost curves, right? Now, if a new pizza restaurant enters this market, now why would a new pizza restaurant enter this market? Well, the entrepreneur that does this is either dumb, or maybe the entrepreneur has gone to these restaurants and he has observed the owners of these restaurants driving up and parking a Lamborghini in front of the restaurants. So if you're an entrepreneur and you see a guy driving a Lamborghini walking into his restaurant or her restaurant and managing it, what do you think? And you're probably thinking, oh, there's money to be made here, right? So if you think that and you're willing to take a risk, roll the dice, then you might open up a 13th pizza restaurant in the market, right? You also have noticed that each restaurant is supplying 23 pizzas, maybe per hour on average, right? So you're going to enter this market thinking that you're going to be able to supply 23 pizzas, right? So supply is going to move, the new supply curve is going to shift to the right. It's going to shift to the right by 23, right? And that's what this equation does. Okay, so we need to copy this equation. This is our new supply curve. When an additional okay. Oh, sorry. I got to do one thing first. This is the original supply curve, right? It hasn't shifted yet. It's still 167.92, right? It hasn't shifted yet. Okay, so if a new pizza restaurant enters the market, the number of restaurants in the market increases to 13, and that new restaurant begins supplying 23 pizzas. So now you have how many, how much quantity is being supplied now? Well, you got 23 times, not 12, right? You have 23 times 13, right? Times 13. It's also, we could get that by adding 23 to 276, right? We had the same number. So at the moment this company enters the market and starts supplying 23 pizzas, right? The market supply increases to 299, which shifts our supply curve from black to blue, right? And it alters the supply curve here, right? Let me change that blue. Okay. Now, if I keep my price, if I keep the price at, what was it? 17? If I keep the price at 17, I'm going to edit this so it's not blue. I'm going to edit it so it's dash line and 0.1 in black. Okay, there we go. Okay, so if I hold the price constant at 17 here, right? Notice my quantity is 276 on the old, at the old equilibrium. At the moment that firm enters the market, quantity supplied goes up to what? 299. But where's the market price? The market price, the new market price is down here, right? The new market price is down here. So at the moment that firm opens and starts supplying 23 pizzas, the market is flooded with 299 pizzas, right? And at this price, only 276 are demanded, right? So we have supply, quantity supplied exceeding quantity demand. And so as a result, what do the firms do? Well, they don't want their pizzas to go bad, so they scale back their production, right? And together, they'll produce only 291.41 pizzas, right? They'll scale back production. And that pushes the price down to the market price of 11.92. Okay. Okay, so the shift in supply results in a new equilibrium quantity. What was that again? 291.41. And a new market price, the new market price is, it's either 11.91 or 11.92, because I'm not sure if this is 5 when it's rounded. It might have been 4952 before it was rounded 3 decimal places, or it might be 5132, right? So we got to, if 11.91 doesn't work, we'll do 11.92. Okay, cool. At this new equilibrium quantity, each restaurant sells what? Well, the 13 restaurants now will split the 291.41, right? Let me just check something real quick. I'm going to make this Q equal to 291.4. So yeah, the price, notice right here, the price is 11.91, right? Because that's a 4.7. So we got that right. All right. So I'm going to divide this by the 13 because there's 13 restaurants, right? So each restaurant supplies 22.416 on average, right, per hour. At 13 restaurants now, and each supplies 22.416 pizzas per hour on average, right? Though more pizza was produced, right, and offered for sale. Before the firm entered, there were 276 pizzas supplied. Now there's 291.41 pizzas supplied and sold, right? So the quantity, the market quantity increased, right? The market quantity increased. So more pizzas were made and sold. So more pizzas were made and sold, right? Each restaurant saw what? They saw their revenue rise, hired more chefs to make more pizza, saw their profits rise, sold fewer pizzas, sold more pizzas. To answer that, you have to compare this number here. This is what each of the 13 restaurants supply after the 13th one entered the markets, right? This is what each of the 12 firms supply before the 13th enters the market. So what happened to the quantity supplied? Right? The quantity supplied. Okay, so saw the revenues rise, hired more chefs to make more pizzas. They didn't make more pizzas. Saw their profits rise. We don't know. Sold fewer pizzas, right? Sold fewer pizzas. Now, what was revenue What was revenue? What was restaurant revenue before 13th restaurant entered the market? Well, the price is 23, right? So this is the revenue. This is the revenue before 13th entered the market when there was only 12. 23 times 17. Each is supplying 23 pizzas at $17 a pop, right? So the revenue before the 13th end of the market was $3.91 in my case. After that 13th end of the market, revenue did what? Now, with the 13th in the market, the revenue of each firm at the market price of $11.91 times each of the 13 restaurants is supplying 22.416. So the revenue of each firm is lower, right? 266.97. So revenue fell. Why? Well, price came down. Each store is faced with a new lower price, and they're supplying less per store, right? Per restaurant. Yep. Now, if the economic profits of each of the 13 restaurants is now zero, right? Why did that firm enter the market? Why did that 13th entrepreneur enter the market? Because that 13th entrepreneur saw that the 12 owners of the pizza restaurants were driving around Lamborghinis, which indicated to this guy that there's excessive economic profits to be made in that market, which is why the guy rolled the dice and entered the market and became the 13th pizza restaurant, right? So now, what we learn in pure competition, over the long run, there are zero economic profits in the long run, right? In the short run, a firm can't enter. There's not enough time, right? You have to build a restaurant, yada, 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 right? But over the long run, firms are free to enter the market. So over the long run, there's going to be zero economic profit, right? Over the long run. And that 13th firm can enter over the long run, not in the short run. In the short run, that entrepreneur is eating pizza at the 12 restaurants, right? But in the long run, they open that 13th restaurant, right? In the long run, there is no economic profit. Economic profits are zero, right? Now, we're going to use this information to calculate the economic profit prior to the 13th restaurant entering the market, right? So the revenue minus the cost, right, equals what? Zero, right? So revenue of each firm, the one means after, the zero means before, right? This is before and after revenue, right? So R1 here is the revenue after the 13th restaurant enters the market, right? The last one enters, right? 13th. And this is the cost, right? And what we said here is that economic profit is zero, right? So if this is true, then restaurant costs are equal to the revenue, right? Right? So this right here comes from this assumption that per restaurant economic profits are now zero for each of the 13 restaurants, right? So revenue after that 13th restaurant enters the market is 2266.97. Because economic profits are zero, the cost must be 266.97, right? Now we're assuming what? Restaurant costs are unchanged before and after. So we're saying this is the cost before the 13th restaurant enters the market, and this is the cost after the 13th restaurant enters the market, right? And we're assuming that because maybe fixed cost in this example dominate variable cost, right? So there's a small change in variable cost, no change in fixed cost. So the change in total cost is negligible, right? So now all I'm going to do is I'm going to take the revenue for each restaurant before 13th restaurant entered the market. I'm going to subtract from it the cost. And so there was a profit to be made prior to a firm entering the market. This is why the 12 owners were driving around Lamborghinis, right? And that attracted the attention of this entrepreneur who opened up a 13th pizza restaurant. Yep. Now we're going to do question two. Question two is similar, but what is the moral of the story here? In the short run, you can have a profit, right? A handsome profit, a handsome economic profit. And if you tell everybody that you're making a handsome profit by living in a brand new house, massive brand new house with a Lamborghini in the driveway, people are going to ask questions. Well, how does that person get the kind of wealth to be able to afford that house and that Lamborghini? Well, then they follow you around and they see that you own a restaurant. That restaurant must be producing above normal economic profits. So a person willing to take risk and roll the dice will enter the market. And that does what? It lowers the price, right? It lowers the price. So competition leads to lower prices, more output, and reduces economic profit to zero, right? That's the moral of the story. So what to do, right? What can you do? Well, you may decide to monopolize the market, and that's the focus of the next question.